So we kind of talked about this briefly on Friday. My goal is we're going to get through the whole assignment. We're all going to submit it kind of at the same time. And then that way we can turn around and do the notes. We can get as far as we can on the notes and start catching ourselves up because we are a little behind a lot of the other classes. So I want to work through this whole assignment with you. And that way you guys kind of get those answers. We just get it turned in, okay? Especially you guys who haven't opened up the assignment yet, make sure you have it open. All right, so the whole idea of the assignment itself was that we are trying to give these electrons an address. Just like our address, if we were trying to locate you, you have, we have an address, we have a number, a street name, a city, a state, the planet Earth, right? We have all of that. And if we want to get really specific, you could say what school, what room in the school, things like that, right? So just like that, we're going to be talking about that for electrons as well. Yeah, it was C, exactly. First floor, second floor, front, back, yeah, exactly. So we're going to get that specific with these electrons as well, all right? So we kind of talked about this first question already. We were deciding what the different symbols were, okay? So we had our borders, which were the dot, okay? Then you had your bunk beds, and then we had our manager's code. And just as a reminder, the boarding house, you can think of it kind of like a dormitory. And so the whole idea of this boarding house is that we had two sides of the house. We had sunny rooms, we had pink rooms. We had bunk beds in there, and there's a certain number of bunk beds. So we only have one bunk bed versus 3 bunk beds. And then you had a certain number of people and a certain way of filling up all those bunk beds. And you can't share a bunk. So we don't have any 2 people in the same bunk. You're either on the top bunk or you're in the bottom bunk. You don't share. And those are going to be important for us. Now, you guys have on the periodic table, basically this boarding house is the periodic table upside down. Okay? So we have our first floor sunny room, second floor sunny room, second floor pink room, third floor sunny room, third floor pink room. All right, so it is your periodic table, and so that's going to be important. The number of borders is our number of electrons. Remember, number of electrons matches up to our atomic number, okay? So 14 people in the house is talking about silicon, all right? All right, so with that, excuse me, moving on to number 2. You had to figure out something at 5 p.m., so this is the one we talked about. So what we did on Friday was we counted up the number of dots, right? So we said 1, 2, 3, 4, 5, 6, 7, 8. So we put number 8, and then we said, how did you determine that answer? Well, you just saw me. We counted it up, right? So you should pick the answer that says counted up, or you counted all the black dots. There you go, okay? Huh? Okay. So over here for number 3, we had to talk about the manager's code. And so with the manager's code, we were talking about the floor number, just like she said. We had our room type, which was S or P, sunny or pink. And then you had the number of people was the little exponent up in the top right. So those of you who are just starting the assignment, are you keeping up? Are we doing okay? Okay, good. All right, so we are now going to go to number 4. Okay, so for number 4, it said the manager had strict rules on how to fill up all of the beds, right? We don't just say, okay, you can have whatever room you want, whatever bed you want. It doesn't matter. That's not the way it works, right? So we have, like I said, specific rules. So the first rule says the boarding house will rent out the beds on the first floor first, which is what we see in this picture, right? First floor handled first, then we went to the second, and then we went to the third by the end of the day. Okay, so first floor first. Boarders are only allowed to occupy the top bunk.
When all the bottom bunks are occupied.
Exactly, when we have all the bottom bunks occupied. So here, we didn't throw this person up on the top bunk, right? We filled up the bottom bunk first and then filled up there. Here you see that we start filling up once all the bottom bunks were full, okay? So you're absolutely correct on that. So all the bottom bunks are occupied would be the one to pick. Letter C said the next floor of rooms will be open for boarders only when all of the bunks on the floor below are occupied. So what this kind of means was that we didn't just put somebody on the first floor and then throw people into the third floor. Like, that doesn't happen. You have to fill up your floors in order. So bottom first, and then you move up to the third floor eventually, right? It's going to be the same way when we're dealing with the periodic table. You have to start at the top of the periodic table. You can't just jump down here and be like, I'm going to start with rubidium way down here. You can't do that, all right? So you got to follow the process of your periodic table and follow it from left to right, okay? All right. That's what's coming. Okay, last one, the pink room on a floor will be open for boarders only when, I forget, hold on.
All the bunks in the sunny room.
Perfect. All the bunks in the sunny room are occupied. It's the middle answer. We're good. Yes?
Mm-hmm.
Perfect. All right, number 5. Sorry. So number 5 was asking us to fill up for 11 boarders, or 11 people. So we had 2 to begin with, okay? So we have 1, 2. We go to the next floor. So we filled up the first floor. Now we can go to the second floor. We have to fill sunny before pink. So we're going to go sunny room first. We're going to fill it up. Then we're going to fill up all of the pink room. And at this point, we now have 2, 4, 6, 8, 10 total people. So we have to get to 11, which means we're going to put 1 more on the third floor. So we're going to put the 1 person on the third floor sunny room. And then we're going to put the empty ones for the pink room, as in nothing else got filled. Does anybody have any questions on locations of these? We're all good? So the next question is asking you to put in the manager's code. So just looking at this, right? Remember, we're going to talk about the floor, the room type, number of people. So 1S2, 2S2, 2P6, and so on. A lot of you guys found that little loophole on number 6, which was that the answer was right there. It was the 7 o'clock house. Okay? So you should have been typing in, or if you want to look at the picture for the 7 o'clock house, that's the one that has 11, right? So we would say 1S2, as in there is 2 people on the first floor, sunny room. Then you say 2S2. Then we would go to the pink room. 2. Oh, I hit the wrong 2. Sorry, guys. Hold on. There we go. 2P6.
What's the last one? Does it keep saying for the letters? No, for the letters.
3S1. This one right here? Or are you talking about over here?
When it says for the letters, it has S, P, and then D.
Oh, D is going to be your transition metals. There's D and then there's F, which is the 2 rows down here.
Oh.
The bottom, yeah. That's coming. That's coming up. You'll get there. Hopefully today we'll get there. All right. Don't freak out. That's super easy. You just follow the periodic table. Just follow it across. Remember that. Just follow it across. Okay. All right. Number 7. Number 7 should have just been information. It was telling you ape, the eighth part of 8-man, right? Atomic number is equal to your protons, is equal to your electrons, meaning if we know the number of electrons, as in we counted up all these little arrows, we know the atomic number. So just to kind of test that for a second, look at your periodic table, because you guys all grabbed one, just kidding, or you have your own. But if you don't, that's okay. I'll put my periodic table up here. If I were to say, okay, you have 17 electrons or 17 arrows, what element am I talking about? If I say 17 arrows. Who? I heard you say it. Say it louder. Who?
Chlorine.
Chlorine, exactly. So I said there are 17 arrows. So 17 arrows says, okay, there's 17 electrons. So I'm going to look for atomic number 17 right here. That is chlorine. That's the way to use those, the number of arrows and those little exponents. Okay? All right. Cool. Awesome. So, number 8. Number 8 was asking you to now talk about this, but we're using our fancy words. So, honestly, in my opinion, maybe number 11 should have come first and 8 should have been there, but that's okay. We're going to go with it. So we got to match up these different things with the words that are down here. So, we had our little box. That is an orbital, exactly. Does anybody want to take a stab at what that was in the boarding house? Not the room.
The bunk bed.
The bunk bed, exactly. The bunk bed. All right. Here, the up arrow. What is that representing? I think we did that one together. Okay, single electron. Perfect, which was a boarder or a person. All right, the 2 would be the pair of electrons with opposite spin. So that's the bottom bunk, top bunk, people. Then we had 3 of those bunk beds together, and that made up our room type. So the fancy word for that is going to be a sub-level. So we're going to see energy level, and we're going to see sub-level. Okay? And I'll make sure that I make the connection on what it looks like on your periodic table. And finally, that manager's code is known as electron configuration. Okay? Huh? I'm sorry. Okay. Anybody have any questions over this little list? We're all good? Okay. All right, number 9. So number 9 was asking you, so this one, everybody misses this word. It's right here. It says, it's telling you specifically to look at oxygen. So good job if you caught that, or if I went over it last week, cool. Awesome. So we have to look only at oxygen. So up here on your little picture, oxygen, I highlighted it right here, is this diagram. So you should be looking at the top right diagram, okay? So real quick, just looking at your periodic table, how many arrows should be in that diagram without counting the arrows? Just looking at this little snapshot of our periodic table. How many electrons or how many arrows? Anybody have an idea? For oxygen? Oxygen is this O, by the way.
8.
8? Why? Because the atomic number is 8. Okay, so that's kind of the connection that I need you guys to be making here, okay? All right, so there are 8. And if we go back, we say 1, 2, 3, 4, 5, 6, 7, 8. Cool. So we had 8 electrons. Remember, electrons were the arrows. So the way we did that was we counted up the arrows. The way that we know it is the same thing is because it is the atomic number for oxygen. So the atomic number for oxygen is 8. Any questions on that one? So that's kind of a key concept. Make sure you remember that while we're going through electron configuration. This chapter can be super hard, but it can also be super easy if you just kind of keep your analogy in your brain, okay? And try it. Don't forget 8-man. Those things don't go away. All right, number 10. Let's go to that. Number 10 is asking for us to now put those vocabulary words, so the chemistry words in for what we had said earlier about this manager's code, right? So this was our floor level to begin with. So now what do you think that's going to be? If it was our floor level, so it was talking, so I showed you this, right? And I said first floor was row 1, row 2, row 3, right? First, second, third floor. Okay, what did we also call those when we were doing the Bohr model? Because we know they're periods. Does anybody remember?
Sublevels?
No, we haven't used that word yet.
Energy level?
Energy level. It was energy levels, right? And you guys saw that with your flame test lab. If you noticed, I think there was a question asking you how did they relate in the same group. No, I think I took that question off. But you had like lithium versus potassium. Does anybody remember what color lithium was? I don't know, my computer's sick. Does anybody remember what color they got for lithium? That was the one that was back there.
Purple?
Nope, that one. No, it was red. Do you guys remember? It was a very bright red in the back. And what did we get for potassium? That was the mystery one as well. That one was purple, okay? So if you look at where these things are located on our periodic table, okay, lithium up here, potassium here, and Sodium was technically orange. You guys didn't get to see that one. But it goes red, orange, purple. So if this is true, energy levels, didn't your energy technically get bigger by that color, right? If you think about it, the high energy had the highest part on the on your electromagnetic spectrum, right? So just kind of keep in mind, that's where we're kind of getting this connection, okay? So it has to do with your period numbers are your energy levels. So that's the first thing that you always describe. What row on the periodic table am I at? Then we have S. So that was a room, right? So that would be our sublevel. So if you remember from this question, we said a sublevel was a set of orbitals. It was a room of bunk beds. Okay? So that's where that should be making a connection. Okay. And then finally, the last thing is your number of electrons, which I think most of us have caught on that that's what those little numbers have done. All right. Any questions on that? We're going to need those words in a second. We're all good? Perfect. All right, number 11 then. Okay, so number 11 goes into rules. Now, what I kind of told classes earlier was I don't mind. It's not important to me that you know exactly what the rule was called and what it does. What's important to me is that you are applying all three of these rules every single time. You don't break a rule. Do we understand that? Do I care if you know if it's off-ball? Not necessarily. Is it good to know? Yeah, you should probably just try. But that's not what I'm going to test you over. What I'm going to test you over is saying, can you apply off-ball principle, all right, and Pauli exclusion and Huns rule. So looking here, it says based on where a single electron is placed, okay, so where a person goes in the boarding house, the lowest potential energy electron in an atom is found in the what sublevel? All right, where does the first person get placed in the boarding house? Where does the first person get placed? So I'll go back here to our little manager code right there. Where does the first electron or where does the first person get placed? First person was in the first floor, right? So let's see what our answer choices are. The 1S, the first floor sunny room, okay? Same thing, so first floor sunny room. That's what it's asking for. All right, electrons will occupy a p orbital, so a person will go to the pink room only after. So when did they start going to the pink room? After what was full? The S room, right? Was completely full. So only after the previous S orbital is completely full. We should say the S sublevel, but that's okay. Okay? All good? Letter C, electrons can begin to occupy your energy levels with the next highest integer destination. So this sounds like a lot more complicated than what it is. So why we go 1 before 2, 2 before 3, all that stuff. So it only goes to the next floor and only goes to the next floor after the previous one is full. So all of the orbitals on the energy level below it are occupied. So we have 1s, the previous s orbital is completely full, and then all of the orbitals. All good? Any questions so far? Remember, keep it straight with the analogy, and it makes it a little bit easier. Remember how the house got filled up. All right, number 12. So number 12 says, the Pauli exclusion principle can be expressed as if two electrons occupy the same orbital, they must have. All right, orbital is bunk bed. What did we say? If they are going to be in the same bunk bed, where do they go? Can they share the same bunk? No, where do they go? One on top and one on bottom, right? One on top, one on bottom. So they have to have opposite spins. They have to have different bunks, okay? So what they're talking about spins, one is going forward, the other one has to go backwards. These electrons want to be as far away as possible from each other. They're all negative, right? So they want as much space as they can, and they don't want to be alike, okay? All right, so opposite spins. Good. Number 13, Huns Rule. So here's another one where I don't care if you know the name or not, but you got to apply it. Huns Rule describes how electrons are distributed among orbitals in the same sublevel, and there's one more or more than one way to distribute them. All right, so what this kind of matches up to is looking at this, okay, what's an easy way to describe this with the analogy? It's think of the bunks. So what does this tell you? What are all of those bunks? They're empty. So are they completely empty? These are completely empty, right? But these, what is this telling you? They're all what? Which ones are empty? The bottom or the top, right? So all of these people got shoved into a top bunk, top bunk, top bunk. So they have their own space, which is awesome. Because honestly, if you're getting shoved into a room, you don't really, unless you have to, you don't want to have to share it with a stranger. Like, you want your own bunk. You want your own bunk bed, okay? So you want your own space. Just like that, the electrons are the same exact way. And then once we get to that limit, then we have to start putting them into the other bunk until we fill up that room. So fill the bottom bunks up first, or fill the top bunks up first, okay? So electrons will only pair up when all the orbitals have at least one electron. So all orbitals in the same sublevel have one electron. When there's only single ones in there, so this example, do we have one going up, one going down, one going up? No, they all have to either be all top or all bottom. That's it. So they all have to have the same spin. So make sure you mark that answer. All have to have the same spin when they are by themselves. Once they pair up, then they go opposite spins, and you don't share bunks. All right, number 14. 14 is matching up. Basically, I've kind of been doing this, so I think you guys can handle this. What is the box when we're talking about the analogy? So we said it was an orbital. So what was it with the analogy? A bed, a bunk bed, exactly. Good. So we have a bunk bed, which handles 2 people. Okay. Here we had a set of orbitals, or a sublevel. So what would that have been? The what? The room of bunk beds, yep. So the room type. Sunny or pink room. This was a pink room right here. That's what that's showing you. All right, this one electron would be a single border. So just a border. Whereas the opposite spins, one going up, one going bottom, would be a border on the top bunk and the bottom bunk. Or a person in the top bunk and a person in the bottom bunk. That's what that shows. And then finally, manager's code is still there. All right, let's finish this up. Number 15. Number 15 is asking you to use those rules. Now, this is probably the only time that I will be like, hey, which rule is it? So I'll kind of help you out with it, okay? I won't ever test you like that. All right. So looking at this, okay, what is wrong with this picture? Even if you don't know what the rule is, just describe what is something that you see that is wrong in this picture. The top level, good. Should there be anybody in the top level? No, they got to fill up the bottom ones first. And also, there shouldn't be anybody in the pink room because Sunny room still has room, right? All right, so everybody go ahead and mark off bar. Mark off bar for that one. All right. Letter B, is there anything wrong here? I'm seeing a couple people go like that. No? All right, you're right. It is absolutely correct. So this one has all the bottom bunks showing. That's what it's saying, okay? So it doesn't matter which one you start with. You do all top or you do all bottom, as long as they're the same as they're by themselves. And the last one, what's wrong with that one? What's wrong with this? Well, there's one going up, yeah, but what about this? Were they allowed to already share A bunk bed? No, not yet, right? They got to get their own space first, and then they start filling it up. So that one, I believe, is your Huns Rule.
Which one is this?
This is 15. Okay, so for number 16, I'm going to have you guys do that right now on your own. Okay?
Can you show me number?
No, just a second, please. Okay. So you guys are going to do 16 on your own and turn it in. You guys are all going to submit it, and then we're going to turn around and we're going to do our notes. Okay? So I'm going to give you guys about 3 minutes. I don't mind if you ask each other for a little bit of help. That's fine. But get this done. Turn in this question, and then we're all done with this assignment. All right? So thank you for hanging in there. You did a good job. I'm going to turn on the lights. 3, 2, 1. Hold on.